Good evening to everyone. Good evening to all the panels and to my advisor. Let me present my proposal to everyone, which is entitled Small Scale Underrun Disk Sheller with Variable Slip Speed and Replaceable Disk Type for Peanut Variety. Dehusking equipment, also known as dehuskers, huskers, hullers or shellers, remove the paddy husk of the paddy grains such as the rice. The most common types of this equipment, we have steel huller, rubber rollers, and underrun disc sheller. Many technologies have been tried, but these are the most economical in commercial operations. And even though these technologies were originally designed and used for dehusking grains, but there is no reason that it cannot be extended or used to other tropical crops. This underrun disc sheller, or simply called disc sheller, has the following features. It has two horizontal discs which are coated with abrasive coverings. The upper disc is fixed while the lower disc rotates, and the lower disc can be adjusted vertically to adjust for the clearance depending on the size of the object and the condition of the grains. Its main advantage is that it is very simple in operation. It has low running cost, and the abrasives can be remade on site with inexpensive materials. But it has a high grain breakage, and it causes abrasion on the outer bran layer of the rice grain. So the basic principle of this technology is, once the object or crops or grains are fed onto the center of the machine, it starts to move radially outward. It is then distributed evenly on the surface of the rotating disc, and under the influence of centrifugal force and the friction force developed, most of the grains are dehusked. So ideally, this technology employs the work of friction that is developed between the interfaces of the shells and the disc by disc rotation. But again, it is observed that it has a greater number of breakage. The reason for this is excessive friction work that is produced by rapid disc rotation with minimal radial displacement due to centrifugal pressure. In other words, the ratio of friction work that is created to the centrifugal force cannot be adjusted. So you can, once the rotational speed of the lower disc is set, the centrifugal force and the friction force are already set, and therefore their ratio is also unchangeable. So in an attempt to move the grains radially outward, it receives an excessive work of friction because you cannot regulate the friction force that is created between the two discs. So the perceived solution is to allow the upper disc to rotate as well. And this can regulate the amount of friction that is generated, because you can have the same speed, you can have enough centrifugal force to move the grains outward, but you can control the amount of friction work that is developed by regulating the relative speeds of the two discs. So it is the general objective of this study to develop a small-scale underrun disc sheller with variable slip speed and replaceable disc type for peanut variety. Specifically, the objectives are: 1. To develop an underrun disc shelling technology that minimizes seed breakage percentage by providing a variable disc speed that regulates the centrifugal effect. Fabricate the system with the following components: top and bottom rubber disc housing, 2 induction motors, control unit, collection box, airflow system, and pedestal. Third, test and improve the project prototype. Determine the effect of clearance, slip speed, and peanut variety, these are the predictors, on the performance indices of the shellers. These are the response. The performance indices are percentage effective cracking, percentage of breakage, percentage partially cracked, and percentage untracked nuts. And last objective is to evaluate the acceptability performance of the project prototype. Let's now go to the conceptual framework of the study. So, this is the summary of the mechanism of action of breaking of the peanuts. First, we have 2 possible cases to begin with. We have case 1 or case 2. In the case of case 1, after the object or the grains are fed onto the center of the machine, one possible case is that it just sits on top of this one. So it moves rotationally, but it does nothing. Case number 2 is also possible. In this case, the object is pressed by disc 1 and disc 2. It happens only at an instance, because after this case 2, it will suddenly move to case 5, 3, or 4, and those are the possible outcomes next to this case. But out of those 3 possible outcomes, case 3, case 4, and case 5, the most probable and frequent to occur is that of case 5. So remember, case 2 is a static setup. Case 5 is dynamic setup. In this case, the object or peanut is rubbed against disc 1 and disc 2. And as you can see on the breakout section, the object has relative velocity with respect to upper disc and lower disc, and therefore we have 2 kinetic frictions that act on breaking the peanut. After this case 5, the next possible outcomes is that of case 3 and case 4. But in this particular situation, FK2 and FK1 can act simultaneously, or it can also be possible that FK2 acts first in breaking, or FK1 acts first in breaking the peanut, and that is the case for case 3 and case 4. Before I forgot, at this stage, this is where breakage occurs. In case 3 and case 4, they are very similar. In case 3, the object is attached to disk 1, therefore there is a static friction force at the bottom while there is kinetic friction force at the top. The reverse of case 3 is that of case 4, where the object is attached to disk 2, which is the upper disk. Therefore, there is static friction force at the top while there is friction force at the bottom. So in case 4, it is rubbed by disk 1. In case 3, it is rubbed by disk 2, the upper disk. In this particular stage, there is a partial breakage and a partial transport of material which is tangentially outward, which is displaced tangentially. And after the case 3 and case 4, since the objects are broken down into smaller pieces, the next possible scenario will go back to case 1. And the case 1 is that the object just sits on top of this 1. So the size has become smaller than the clearance. So it will transition back to case 1. And after that, the broken peanuts will be located at the periphery of the disk. And further addition of objects will move those broken peanuts and shells to fall outside the disk. And the cycle repeats. This analysis will be helpful in describing the findings which factors affects which performance. Let's now go to the methodology of this study. So the materials will be 4 to 5 months old of Iclisat peanut variety that will be procured in La Carlota City, and also the prototype. After this, the peanuts will be preconditioned by solar drying and manual cleaning. And then the initial moisture content will be measured using the AOAC official method, using the binder ED series oven drying in the school. Next is, since this study is experimental, there is no need yet for optimization. So instead, what will happen is the discretization, but it is a two-stage nested experimental design. So the first stage is to look what value clearance is providing a better result, and then after that we'll go to the second stage, which is adjusting the slip speed, which has 4 values, and the Iclisat, which has 2 peanut variety. For slip speed, we have 4 values because in the proposed design, the upper disk has 1 speed arrangement only, and that is omega 2. But the lower disk has 4 possible arrangements, since in that design there are 2 pulleys and 2 pulleys side by side, so we can have 4 arrangements of the pulley. Therefore, we have 4 possible speeds at the lower disk. So we have 4 values because slip speed is defined as the absolute difference between the lower disk and the upper disk. So we have 4 values for slip speed. So for a full factorial design, the number of experiments will be 2 times 4 is equals 8. The number of replications, I mean. Next, after this, we go to testing and visual inspection of the quality of the broken peanuts, the successfully broken peanuts, and the shells will be computed. And lastly, the data will be analyzed using general linear model in Minitab 18. Lastly, this is the table summary of the variables, the data, and the instrument and procedures that will be followed during the study. We have the 2 predictors, the slip speed, and the peanut variety. And the performance indices, we have percentage effective cracking, percentage of breakage, percentage partially cracked, percentage uncracked ducts, and the independent response, which is winnowing efficiency, that will depend on the effectivity of the fans. We have also the controlled variables, and that is the age of peanuts, between 4 to 5 months, and the moisture content. And the extraneous variable that cannot be controlled is the peanut size. And last, the possible intervening variables is the moisture content and or the clearance. That's all. Thank you for your attention.